What's going on, everyone? Welcome back. Patrick here, and in this video what I'm going to do is introduce you to the concept of a density curve, and I'm going to introduce it through this example over here. Now, this example you'll find in the lecture notes, so if you don't want to write all of this down, you can print out the lecture notes. It'll be at the beginning of the section. If you're watching it on YouTube, you can find a link to the lecture notes in the description box. Now, in those lecture notes for this example, what you're going to see is actually two tables. And here I only have one of the tables drawn out. And that's to save myself some room on the whiteboard. But that second table, all it is what we did here was we took a sample of 2,000 people with their respective incomes, and we made intervals, and then the number of people fell in each of these respective intervals. And then that second table, all it is that we have more intervals. So instead of going 20 to 40, it'll be like 20 to 30, and then 30 to 40, and then 40 to 50, etc., etc. So it's the same data, it's just that there's more intervals now. So the intervals are going to be smaller, and there's going to be more of them. And I'm going to bring back that table later on in the video because it's pretty crucial in explaining how this density curve comes about from data. But for now, I'm just going to focus on this first table, but I will bring back that second table later on in the example. Next thing I want to mention before getting into this example is that I'm going to show you how we go from a histogram, which we've already covered. From a histogram, we can also create something called a polygon, which is a new concept I'm going to introduce in this video, but it's super simple. Once you have a histogram, making a polygon is really easy, as I'm going to show. And then from there, how we go to a density curve. So there's going to be a bit of a process in this video with this data. I'm going to be making a histogram. I'm actually going to be making two histograms. There's going to be a frequency histogram and then a relative frequency histogram. A frequency histogram is what we've mostly been showing so far, where the y-axis is the frequency, the number of observations, while a relative frequency is the y-axis is going to be the proportion or the percentage. But again, I'm going to show you how to make that from the data, and this is the sort of process, the general process we're going to follow in order to explain what that density curve is. So I'm going to show you how it comes about naturally instead of just giving it to you and you perhaps not understanding what it means. Okay, so as I said, we sampled 2,000 people. So if you notice, these numbers here, they'll add up to 2,000, and their respective incomes. So this first interval here is all the people that have an income from 20,000. Remember, these are all in thousands. So from 20,000 to less than 40,000, 200 people are in that interval. Then 40 to less than 60,000, 900, 60 to less than 80, 800, and then 80 to less than 100, 100 people. And so what we can do, what I'm going to do is make a histogram on this. Now this here is going to be a frequency histogram. Just want to make that note as well. Because notice that this is a frequency table. This here is the frequency, this column. Okay, the number of observations, in this case, the number of people that fall in these intervals. And so remember, the x-axis of a histogram is always these intervals here. It's the quantitative variable that we're looking at broken down into intervals. So we're going to go 20, 40, 60, 80, 100. So this would be 20, 40, 60, 80, and then 100. And this is income in thousands. And then this here, the y-axis, is going to be the frequency or the number of people. It's going up to 900, so let's go up by 100. So we'll have 100, 200, 300, 400, 500, 600, 700, 800, and then we'll have 900 up there. And so if we make a histogram, this interval, 200, which is this interval here. So this would be 200, like that. 40 to 60 is 900 people, so that's going to go all the way up there. Then we're going to have 60 to 80, which would be 800. And then we'll have 80 to 100, which is just 100, so down over here. And up here is 900 and 800. So this here is a frequency histogram of this data over here. But what's going to happen is a density curve on the y-axis, it's not going to be the number of observations, it's actually going to be the percentage or the proportion of data. And so to show you how we're going from a histogram to a density curve, what we want to do is instead of having the number of people on the y-axis, we want to have the percentage of people on that y-axis. And so to get the percentage, all we have to do is see what percentage of the 2,000 people that were sampled fall in this interval over here. So we'll take 200 divided by 2,000, multiply it by 100, that would give us 10%. And then 900 of 2,000, that would give us 45%. This would be 40%. 800 of 2,000 is 40%. Then 100 of 2,000 gives us 5%. And this column here should add up to 100. And notice if you do add up all those numbers, they will add up to 100. And if you were going to put these numbers in decimals, so like 0.1, 0.45, 0.4, 0.05, they should all add up to 1. I'm going to just keep it as percentages here. And so to change this to a relative frequency histogram, basically that y-axis just has to be a percentage. Now, the percentage of people from this sample of 2,000. And so what we can do is we can actually go up by 5s if we're changing this to a percentage. So this would be, you may want to draw this new histogram as a separate one. I'm just going to adjust this y-axis just to save time in the video. So we'll have 5, 10, and then 15, 20, 25, 30, 35, 40, and then 45 is going to be that top, which is what we have here. So now notice that that y-axis we changed to a percentage, and if you wanted to have it in decimals and have that y-axis be the proportion, then it'd be the same thing. It'd just be 0.05, 0.1, 0.4, 0.45. All right, so again, I'm going to just keep it in percentages. And now that we changed this y-axis to a percentage, it's no longer a frequency histogram, which was based on this column here. This column here is the relative frequency. And so this is now a relative frequency histogram. Right, where that y-axis again is percentages. Now, I mentioned that I'm going to introduce something called a polygon. So what would a polygon be? And I said that once you have the histogram, it's super easy to make. All you have to do with a polygon is introduce points at the top of each bar in the middle. So we would have a point here, point here, point here, and then a point there. And then all we have to do is connect the dots. So we'll have something like this. And it just gives us another way to look at the data, to represent the data. So I could have maybe made that in a different color, but that line there where we connected all the dots, that's called a relative frequency polygon. Now we can also make a frequency polygon if we had that original y-axis with the frequency here. If we made this same polygon, it would be a frequency polygon. But now, since I changed it to percentages, it's now a relative frequency polygon. And a lot of times, these polygons are shown without the histogram. So notice I erased the bars here and just showed you how the polygon looks by itself with this data over here. Now, a couple of things that I want to mention about this polygon, actually just one, is that notice that the number of dots here, there's 4, and it's the exact same as the number of intervals in this frequency table, or rather this relative frequency table that we are using. So the number of dots of a polygon is always going to be the same as the number of intervals that you are working with, right? Because remember, these dots, they're always going to be in the middle of each of the intervals that you have. So the number of dots is going to be the same as the number of intervals. And so in the next table that we're going to work with for this same data, we're going to have 8 intervals instead of the 4 here. And so when we make that relative frequency polygon for the next table, there's going to be more dots to connect. So drawing out that second table that was in the lecture notes, I have it here, and I'm going to follow the exact same process, create a relative frequency histogram and a relative frequency polygon like we did for the first table. Now, a couple of things I want to mention is we're working with the same data. We're still working with the same 2,000 people. Notice that all of this adds up to 2,000. And if you remember in the first table, the first interval was 20 to less than 40. And how many people was that? That was 200. So notice 20 to less than 40, if we add up these two, 200 people. It's just we kind of spread it out now. We took this interval, made it into 2 intervals here. And then from that first table, we had 40 to less than 60. The total was 900. So notice that this and this is 900. And then the next interval was 60 to less than 80. The total was 800. Notice that these two add up to 800. And then these two add up to 100 for 80 to less than 100. Okay, so we just took those intervals, kind of spread them out, created more intervals. But again, it's on the same data, exact same data. It's just different intervals. But if we compare it to that first table, all the numbers correspond correctly. So in that first table, I created a frequency histogram, but I'm going to skip the frequency part, which is this column, and I'm going to create a relative frequency. So remember, relative frequency, we got to take the percentage of each of these observations from the total number of observations that we're looking at. So notice 100 of 2,000, that's going to be 5%, 5%, 10%. This is going to be 35%. This is going to be 32.5%. This here is going to be 7.5%. Now this 70 here out of the 2,000, that's going to be 3.5%. And then the 30 out of 2,000 is going to be 1.5%. So if you add all of these up, you should get 100. So let's just double check. So we got 10, 20, 55. These two add up to 40, so we'll have 55 plus 40, which is 95. These two add up to 5, so 95 plus 5 indeed gives us 100%. And again, you can also show the decimals of these, so instead of writing 5%, you can write 0.05, 0.05, 0.1, 0.35, etc. You can call it a proportion if you want. I'm just going to keep it as a percentage. So remember, this column here is the relative frequency column. So I'm just going to say it's the percentage, this y-axis. And let's go up by 5s here. So it goes up to 35%. So we'll go 5, 10, 15, 20, 25, 30, 35, like that. So 20 to less than 30, which is this interval over here, that is 5%. So we went up by 5, 10, 15, 20, 25, 30, 35. So this would end up being 5, 5 again, and then we'll have 10. And then Then we'll have 35 to 50 to 60. So that's going to be all the way up here. Try to keep this as straight as possible. 60 to 70, 32.5. So that's going to be like right there. And then we'll have 7.5, which would be over here. And then we'll have 3.5. And then we'll have 1.5, like that. So now this is our new, remember this is the relative frequency histogram. Because we got that percentage on the y-axis. So notice compared to that first histogram when we only had 4 intervals, notice we have more bars now to work with, and each of the bars are thinner. Now to create a relative frequency polygon, what we do is we put dots in the middle on the top of each bar. So here, 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 and there. And then what we do is we connect them. So notice that there are more dots now to connect than previously. And then that final one right here. And notice how many dots there were. So there was 1, 2, 3, 4, 5, 6, 7, 8. Remember, as I mentioned before, same number as the number of intervals. And so notice that the dots now, as you add more intervals, what's happening is that there's starting to be more bars in the histogram, meaning that there's starting to be more dots in the relative frequency polygon, which means that the dots are actually getting closer and closer together. So without the histogram, this is how that relative frequency polygon is now looking. So this here is the relative frequency polygon. Now, what would happen if we added even more intervals? So maybe instead of going up by 10,000s like we are here, we went up by 5,000s. Or what if we went up by thousands or even hundreds? And we really had like a really large amount of intervals. What would happen to that relative frequency polygon? Well, we would start having more dots to connect. And so what would happen is you wouldn't have these sort of edges anymore. So you see how there's like an edge here? Like here and then there? The slopes of the lines kind of change. If we had a large number of intervals and we made a relative frequency polygon with all those extra dots, what you would end up having is something like a curve that looks more smooth, because those dots would be so close together that there wouldn't be these like sharp edges anymore. So the less dots there are, the less intervals you're working with on that x-axis, the more sharper these edges are going to be. And the more dots you have, the more intervals you have, the less edges you're going to have, the more of a curve it's going to be when you connect all those dots. And so if we pretend that this here, we got the income, thousands, and then over here we have the percentage or proportion if we had it in decimals. And so what this is once it's very smooth like a curve without those sharp edges, this here is actually called a density curve. So the way that I like to think of a density curve, it's basically a relative frequency polygon with infinite intervals, or with a very large number of intervals. So if instead of going up by like 10,000s, imagine we were going up by tens, all the way from 20,000 to 100,000. You can imagine how many intervals we would have, how many dots we would have to connect, and it would start looking more like a curve. And so if you had an infinite, as that number of intervals goes to infinity, you get a smooth curve, and that's what a density curve is. So that's how a density curve comes about, right? It's basically coming from a relative frequency polygon or a relative frequency histogram with an infinite amount of intervals. You're probably not going to see this definition anywhere. It's kind of like my own definition that I like to think of. But yeah, that's how it comes about. And we're going to be working with density curves in the future a lot more. One of the more popular ones is something called a normal distribution. It's a type of density curve that is really commonly used in statistics. And what's nice about a density curve is that this y-axis is always going to be the percentage. Usually it's actually the proportion. This is all usually going to be in decimals. And so the area, this whole area here, under a density curve is always equal to 1. Or 100 if you're looking at percentages. But usually you're going to see 1 because this y-axis is usually going to be in decimals. So instead of having 5, you'll have like 0.05, 0.1, 0.15. So the area under this curve, representing all the data with that infinite amount of intervals, is it's always going to equal 1. And so it becomes super useful because what we can start doing is we can start saying something or doing something like, what's the percentage of the data that has an income over 70,000? So 70,000 would maybe be like over here. And so what we can do is we can just find the area of this portion of that density curve. And that area, remember, the total area of everything has to equal 1. So let's say this area was maybe like 0.2. which would mean 20% of the data has an income over 70,000, which means that 80%, because this whole area has to equal 1, that means 80% has an income less than 70,000. So that's the type of stuff we're going to be using density curves for, certain probabilities and stuff like that. But again, this was just kind of an introduction. I just wanted to show you how we come up with a density curve, and it's basically, again, coming from that relative frequency polygon but with an infinite amount of intervals.